Let's take a look at this problem. Find a price will maximize profit for the demand and cost function, where P is the price, X is the number of units, and C is cost. That's little p is the price. So our demand function, little p is equal to 20 minus square root of X. And we don't want to leave that in radical form, so that's 20 minus X to the 1/2. And C, our cost function, is 15x plus 200. Well, our profit, which is what they're asking for, our maximized profit, is equal to revenue minus cost. And revenue is X times little p minus cost. So we got X times little p, which is 20 minus X to the 1/2. Minus, and I'll put a parentheses because that might have to change the sign if everything follows it, 15x plus 200. X times 20 is 20x minus X times X to the 1/2. You add the exponents. There's a 1 here, so 1 plus 1/2 gives us 3/2. So we got X to the 3/2. Negative out in front of a parentheses flips the sign of everything inside. So we've got minus 15x minus 200. So we've got negative x to the 3/2. 20x minus 15x is 5x minus 200. Now we want to take the derivative of that. So the derivative of p with respect to x. Take your power, put it out in front. So we got negative 3/2 x, lower your power by 1. 3/2 minus 1. 5x becomes 5, and then negative 200 goes away. So that gives us negative 3/2, negative 3/2 x, and then 3/2 minus 1 is 1/2 plus 5. Now we want to set that equal to 0. So we got negative 3/2 x to the 1/2 plus 5 is equal to 0, and we want to solve it. Well, I'm going to take the negative 3/2 x to the 1/2 to the right side, so it becomes positive. So we got 5 is equal to 3/2 x to the 1/2. Now we're trying to get the x to the 1/2 by itself, so multiply both sides by 2. So 2 times 5 equals 2 times 3/2 x to the 1/2. 2 times 5 is 10. Here the 2's cancel, and we've got 3x to the 1/2. And now we want to divide both sides by 3. So we got 10/3 is equal x to 1/2. Now x to 1/2 is the square root of x. And remember how to solve a radical equation. Once we got the radical by itself, then you raise both sides to a power equal to the index. Index of a square root is 2, so we'll square both sides. So we got 10/3 squared is equal to square root of x squared. 10/3 squared, square 10, that gives us 100. Square the 3, that gives us 9. And then when you square the square root, they cancel each other and gives us x. $100 divided by 9. Let's see what that gives us. Now I'm just going to round like normal. So 100 divided by 9 gives us 11. So x is equal to 11. Now, if I plug that in to my first derivative, we're going to be limited starting at 0 because negative doesn't make any sense, and over here it'll be positive infinity. Now we want to choose test cases. Like I'll choose x equals 1 and x equals 100. Plug those into our derivative. Well, here's our derivative. Now keep in mind what this represents. This is negative 3/2 square root of x plus 5. If I put 1 in for the x, we got negative 3 halves times the square root of 1 plus 5. Square root of 1 is 1 times negative 3 halves is negative 3 halves, which is negative 1.5. Negative 1.5 plus 5 is positive, so it's increasing. Now if I put 100 in there, we got negative 3 halves times the square root of 100 plus 5. Now square root of 100 is 10. 10 times 30 is 15 divided by 2, 7.5 with a negative. So negative 7.5 plus 5, which is negative, so this is decreasing. So it is indeed a maximum. I think all they're asking for is a number of units. Let's go look. No, price. I lie. So we got x is equal to 11, and we're going to plug that into little p, which is 20 minus square root of x. So we got little p is equal to 20 minus square root of 11, second x squared, 11, enter, 3.32. Yeah, 3.32. Now do 20 minus 3.32. And we get 16.68 as our price. That's the price will give us a maximum profit. Now, I ran an assumption on this problem that x could not have decimals. You know, that we're dealing with like particular items, like scissors or something. You can't have 2.1 scissors. But if we were having a different assumption, that we're dealing like gallons or something like that, then decimals may make sense. So we wouldn't want to round this over here to 11. We'd want to maybe take it to more decimal places, or even maybe leave it in fraction form.